In episode 85 of Mobycast, we introduced AWS Fargate, which brings the serverless concept to running containers on ECS. We discussed the features and benefits of Fargate, as well as how it differs from normal EC2 launch types. Now it's time to dive deeper into some of the details you need to know to successfully run your containers on Fargate. In this episode of Mobycast, Jon and Chris continue their three-part series on serverless containers with an in-depth discussion of identity and access management for ECS. We learn about the various roles you will encounter, why they are needed, and how to use them. We also share a best practice that will make you look like a security pro. Welcome to Mobycast, a show about the techniques and technologies used by the best cloud-native software teams. Each week, your hosts Jon Christensen and Chris Hickman pick a software concept and dive deep to figure it out.
Welcome, Chris. It's another episode of Mobycast.
Hey, Jon. It's good to be back.
Yeah, good to have you back. I have a little something to share with you.
What's that?
Remember how last week I was pretty skeptical that it was going to snow?
Yes, indeed.
Well, everybody here that's listening to Mobycast is obviously listening to it so that they can hear us banter about the weather. But I just thought I'd let you know that it did snow. I was so skeptical. I think that's what it took. It took my 100% confidence that the forecast was false in order for it to actually be true. I was so sure. So yeah, that just meant putting on the kids' snow pants, boots, hat, gloves, everything like that this morning. They're very young, so I have to do that for them. Well, for one of them.
I've got this image of Christmas Story, the movie, where the mom wraps up the kid, the youngest one, and he's like a swollen tick. By the time she's done, he can't even put his arms down. So
yeah, I mean it's pretty much true. I had a hard time forcing Jonah into the car seat today. Bend, I said, young one, get in that car seat. Anyway, so that was my fun story. Actually, let me plug a book while I'm at it, because it's a book by my friend Andrew Blum. I went to college with him. He's a great guy. He lives in New York City, and he wrote a book recently called The Weather Machine. And it really gets into the process, the whole art of weather forecasting and how it works. And it's sort of a journey down that road. And it's written sort of with a popular voice. He wrote another book called Tubes about how the internet works that became pretty popular. I mean, he got to be on Fresh Air from it, so pretty popular. Same kind of deal with The Weather Machine, so everybody should read it. I haven't read it yet. I'm sorry, Andrew. But I know you're not listening, so... Anyway, everybody should read that. Yeah. Okay, so let's get into it today. You want to start us off, Chris?
Yeah, so last week we talked about ECS, revisited that topic. We hadn't talked about it since episode 3 of Mobycast, so almost 18 months ago. And in particular, we kind of mentioned that there's 2 launch types now for ECS. So there's the original, the EC2 launch type, and that's what we really have. It's been the backbone of us using ECS, and that's where you're provisioning, managing, patching EC2 instances, clusters of machines to run your containers. And those are defined and managed by launch configuration and autoscale group and all the good stuff that goes along with just managing EC2s and whatnot.
Mm-hmm.
So since that first episode, AWS has come out with Fargate, which is their serverless approach to ECS, where you don't have to manage a cluster of EC2 instances. And instead, all the underlying infrastructure is managed by Fargate. So completely serverless, you're just defining your task and your services, and you're kind of given the specifications for how much memory and CPU you need, and then it's up to AWS essentially, right, to now find a place for that to run and execute it, and then you are charged literally by the second for just whatever use. You're only paying for the service when your tasks are running, so you don't have to worry about idle time. So we talked about how some of the really good use cases there would be for batch jobs or cron jobs, and these on and off again type jobs where they don't require a 24/7 operation. Those are really good candidates for running on Fargate.
Mm-hmm. We also talked about how I mean, even though it is a little bit more expensive, that at low levels, just the lack of interaction that you have to have with an EC2 cluster could be worth it. The time you save on that in terms of both cost of your own time and opportunity costs of things you're not doing while you're working on that could be worth doing Fargate as well.
Yeah, absolutely. So we went through a quick kind of calculations with pricing and whatnot, and at the end of the day, it ends up being probably about 50% more to maybe even 100% more to run on Fargate versus EC2. Mm-hmm. But you have to look at your scale, right? So if you're talking about like, oh, I went from $20 a month to $40 a month, you can say, okay, that's you're paying double, or you could say I'm paying $20 a month, so I don't have to manage EC2 instances and figure out how to do that, right? So you have to take all that into account. Mm-hmm. So absolutely, if you're at a smaller scale, or just don't want to deal with that, and the overhead associated with that would actually take you more time, then that's another very, very good reason to look at something like Fargate and just serverless in general. Right. So that was last previous episode was really kind of more along the lines of like the theory, if you will, and just how what it is and how it works and the various benefits and specifics to it. So today I thought we would kind of get more practical and talk about, okay, we're really well versed with the EC2 launch type, and that's how our containers run in production now. What does it take to switch those over to have them run in Fargate? Like, what changes do we have to make? Is it? Yeah,
sorry to interrupt, Chris. I do want to move on and talk about those like more tactical or topical things, but I realize that there's still sort of a lingering question that I have that started to come up towards the end of the episode last week, and I'm wondering if we can talk about it for just a minute before we continue.
Sure.
So the question is basically, this is a serverless service in the sense that you don't have to manage servers directly. But it seems to me that you do have to be pretty aware of sizing still. So it's not like Lambda where you basically hand it a function and just say, go. I might have 1 million users. You figure it out. With this one, you do, please correct me if I'm wrong, I think you do have to have some awareness of scale and do some planning around that. Am I right?
It depends on at what level you're looking at it, right? If you're looking at the kind of like more like the atomic unit level, which is like, here's my task and I want this to run.
Yeah.
Versus here's my system and here's my, the entire distributed system and how requests are coming in and how many of them are and like what's the overall performance of the system, right? And so that's kind of a different view of it. So
and it's that second one that I'm more interested in, because that first one you also have to think about with Lambda, right? With Lambda, you can tell it, oh yeah, use a bunch of CPU units or use a bunch of memory or use very little. You have those little controls you can use. But it's the second one that you never have to worry about with Lambda. You could have 10 users or 10 clients, let's call them instead of users, or 10 million. And Lambda's got to figure that out on its own. There's no control levers that you can give it to say, basically, this is what my traffic pattern looks like. Or at least there didn't used to be. There could be now. Amazon changes so quickly. But initially, it was not something that you were supposed to have to think about with Lambda. And I think with this, it is something that, at least initially when Fargate came out, you did have to think about.
Yeah, I mean, so that's an interesting point to bring up. And, really what it boils down to is like, what's driving the request coming through, right? And so Lambda's just like, oh, you want me to run this task, right? And just go this function and just go and run it, right? And so it doesn't have any concept of like what your overall system is, right? It's just saying, here's a unit of work, right? Just go and do it. So something else is driving that, right? And so typically it's something like API gateway. Maybe like if you're trying to run, like maybe it's a microservice you've implemented using API gateway. So now it's API gateway's problem, right? Of how do they scale, right? To handle all those incoming requests. So whether it's, 10 requests a second or it's 1,000 requests a second or 10,000 requests a second, that's API gateway's problem.
Right.
Lambda doesn't know or care either, right? It just has like, oh, you have this function request invocation. I'm just going to go ahead and do it. And they have to scale their workload to address that kind of aggregate demands upon it.
Right. AWS is responsible for scaling that up.
Right.
If it needs to make more machines do that function, that's its job to figure out.
Right. So when it comes to Fargate, we kind of have, it doesn't really change with the EC2 launch type versus the Fargate launch type.
Okay.
Right? Because like with the EC2 launch type, we have to define like what are our resources, right? So we're defining a cluster, and we can say, how many machines are in that cluster. And that's going to give us some amount of capacity, right? And then for our tasks that are running at the end of the day, we're going to be specifying, here's the CPU requirements and here's the memory requirements for these tasks. And then the scheduler is just going to go and schedule that work wherever there's available space on your instances. If there's no available space, then now you're not going to be able to run any more of your request, right? You're going to be throttled.
Okay.
So then you have to tie in things like Autoscale policies, right? You have to do the Autoscaling yourself, right? You have to wire that stuff up to say, hey, I'm going to trigger now changing my cluster size. I'm no longer want to be 10 nodes. I want to be 12 nodes or whatever it may be, right?
So with EC2, you can totally set yourself up to thrash. You can basically set up auto scaling and set up your machines in such a way where demand is greater than supply, right? Like you're getting crushed and you don't have any way of, everything that you've set up, your auto scaling is like, nope, I'm maxed out. Everything's maxed out. And yet more and more people or clients are coming in asking for things than the cluster can handle. It's not going to go higher than what you've set it at, right? So that's true with EC2. Is that also like, I'm getting really specific here. Is that also true with Fargate, or do you not have that control that lets you sort of shoot yourself in the foot and not make your system naturally auto scale to meet demand?
Both EC2 and Fargate, they take into account auto scaling. Okay, right, and so you can change that pool of resources. So the EC2, and when you're creating an auto scale group for your EC2 cluster, you're specifying things like minimum, maximum, and desired instances, right? Mm-hmm. But that's static. If you set your minimum is 2, your maximum is 5, and your desired is 3 or something like that, right?
Right, and that's very concrete to me, right? That's like maximum 5 computers. Like those are 5 virtual machines that are going to be running in the cloud, and I know that it's never more than that. If I throw more traffic at it than those 5 computers can handle, well, that's on me.
Right. Just realize that's not auto scaling though.
Isn't that
right? Auto scaling is totally separate. Auto scaling is all about changing those parameters, right? So you have to create auto scale policies that will tweak those for you. So you do stuff like, hey, if my average CPU utilization is above 80%, I want to trigger an auto scale action. That's going to now go in and change those parameters so that now instead of my max being 5, my max is now 6 or 7.
Oh, so that was my confusion, because I thought that you could also set like caps on your auto scaling so that you don't end up waking up in the morning and finding out that you just spent $400,000 on AWS and you didn't want to.
And you can do that stuff as well, right? You can say like, hey, this is, again, it all boils down to how what your auto scaling policies look like and what you're triggering off of and what your rules are.
Right.
Like you have there's additional work there that has to be done, with the typical system to actually get it to scale and for it to be elastic, right? So,
okay, so I almost have my answer. Go ahead.
Yeah, I'll just say, in general, it's kind of run, walk, crawl, right? And having like really good auto scaling policies in place kind of necessitates having the demand that would drive that.
Right.
And so like for us at Kelsys, there's, we've quite a bit of our workloads just don't have that kind of demand for an elastic workload. Right. And so we don't necessarily have to wire up auto scale policies on our clusters for a lot of our particular workloads. And so again, the same thing's going to be in the Fargate world.
This is where I wanted to go. So I don't understand how that could be, because in my mind, it's like, well, with Fargate, you're not thinking about instances anymore. You're not thinking about individual computers. So help me understand that mapping now inside Fargate. Mm-hmm.
So there's 2 different units of scaling here. So on the EC2 launch type, right, there's 2 things you can scale. One is you can scale the resources that you have in your cluster, right? So all my containers are running in that cluster, and I need to be able to scale that, whatever the aggregate load is on that. If it's not enough and I need to scale, I need to do that, right? And likewise, I can scale down. So that's one dimension of auto scaling, is on the cluster resources itself. Obviously in Fargate, that doesn't apply, right? Because we're not managing the cluster.
Okay.
The other unit of scale is at the service level, right? So when you create a service in ECS, you're going to say, this is how many occurrences of this task that I want running concurrently.
Okay.
Right? So I'm going to say, I want 2 tasks, or I want 3 tasks, right?
Okay.
That's going to give you a certain amount of throughput and a certain amount of load that you can handle.
So you have no idea how many actually, you know exactly how many machines they'll be running on. It's going to be 1 virtual machine per task, because we talked about that last episode, 1 micro VM per task. But you don't know how those are spread across physical machines. It could be that there's more than 1 on a physical machine, or it could be that there's not. That's outside of your control in Fargate. Right.
Yeah. I mean, in Fargate, you're just saying, this is how many tasks I want running for this particular service. Just go and run them. And it's, you don't know, and you actually don't care, right? So the auto scaling part so the other auto scaling is to do it at the service level, where you're specifying, okay, again, what your policies are for your triggers. So now what you're doing is you're manipulating the numbers on number of tasks and minimum percent and maximum percent, right?
Right. And so you may be able to do some imagining about how many actual computers are running your tasks just by knowing how many VPCs you've asked for and what type of computer they're likely using behind the scenes, but you don't actually control that. They are the ones, AWS is the one in control of computers. And you're just saying, hey, this is like 100 task service, or this is 1,000 task service.
Right.
Okay.
Which is what it is with the EC2 launch type too, right? At the end of the day, that's what you care about. You're going to have maybe you have 3 services that you've rolled out to your ECS cluster. 2 of them are reports or admin type thing, and then the other one is this heavily used microservice, and it's the heavily used microservice that's doing 500 requests a second in aggregate, and the other 2 are only doing 10 requests a second in aggregate, right? So it's you're just looking at how do I auto scale my microservice? And so that's going to be by changing the number of tasks that I have for that.
Cool. And then you give it some sort of policy for scaling up or down the number of tasks. That's essentially the same. Okay, it's an auto scale policy, and it might be based on what kinds of things can you base it on? CPU usage, memory usage?
I think, at the end of the day, the sky's the limit. There's a bunch of canned stuff.
Okay.
But yeah, you can do things like CPU, you can do things like memory, you can do, custom metrics. It's going to be very particular to your application.
Okay, cool.
And just what defines busyness or just load for your application.
So this was an important conversation for me because it helps me feel good about a couple points that I'm about to make. One is that serverless purists, I've noticed, have kind of said, Fargate's not really serverless. And the reason is because you do have to have some awareness of this kind of DevOps-y kind of scaling that we just spent 5-10 minutes talking about. You have to know and manage that yourself. And the scaling policy is going to be based on something computery, like memory or like CPU usage, utilization, or something that a serverless purist is going to be like, hey, don't make me think about that too much. And that's why I brought the example of Lambda before too, because you can't control this inside Lambda. Lambda is completely in control of this. And that's why serverless purists are so everything has to be Lambda. So that's one point I wanted to make. And then the other point I wanted to make is that I expect AWS to need to catch up with Google Cloud on this particular feature, because GCP does have a container run system. I think it's called Cloud Run. And Cloud Run, the idea behind it is to be fully serverless, to be like Fargate++, where it's don't bother telling me how many tasks you want running, how much your min and max is. Just put your container here and we'll take care of the rest. You just show us the image and we've got it from there. And there may be some limitations about the types of images you can use, or some ways of managing your spend and stuff. But the idea is supposed to be a little less configuration management than Fargate is forcing people to do. And I expect that AWS is going to want to have an answer for that.
At the end of the day, like I said, we just spent
I stumped you.
15 minutes, going through just, okay, what is it, what is autoscaling, and, how does it work? And there's these different dimensions of it, and how does that work? Right. And it's not straightforward and simple and easy necessarily. Right.
Right. Exactly.
But yeah, I mean, there's going to be continued work in this space just to make things easier. And like, there have been advances here by AWS to start leveraging machine learning to auto-scaling and to kind of do some of that stuff for you as well. So, going forward, absolutely. I would imagine the same thing's going to happen with Fargate and everything else, right? I mean, at the end of the day, like AWS, they want to make this as easy as possible for folks to just get up and running and using, right? Because once you've got your workload running, then now you're actually paying AWS for those services.
Cool.
Yeah.
So should we get started on this week's episode of Mobycast?
Yeah, I think that would be good. Yeah, we'll see how far we get. But hopefully this. I think this is still good stuff, even though we've diverged a little bit and taken a little bit of a sidetrack here, a detour. But it's good stuff.
Yes.
Yeah. All right. So let's get on with the show, if you will. So again, we want to now walk through the steps of what does it take to migrate a container from the EC2 launch type to the Fargate launch type. But before we do that, kind of want to dive into two big topics of ECS that perhaps, aren't as well understood, or, they're just partially known. And so try to go into there and just fill in some of those gaps and to kind of really flesh out the understanding of these two topics. And so those topics are identity and access management for ECS.
Oh, I love that.
So we have lots of IAM roles that are necessary to make all this stuff work. So it's kind of important just to know, like, okay, what are those roles and why do we need them, and which ones should I care about? And then another topic area I want to cover is just container networking. And this is like another big one that, a lot of people, I think, will just kind of gloss over. They'll just go with the defaults because it usually, 97% of the time it works just with the defaults. But just to kind of peel that back a bit more and kind of understand, like, well, how does container networking work? What are the various types that you can choose from? What are the benefits? What are the limitations? And then once we do that, then we can go and actually now let's walk through the steps of migrating our container from EC2 to Fargate, because part of that work is going to understand roles and container networking pretty well.
Cool. Yeah. And if we can save, 10 people, 10 hours on IAM role troubleshooting, there's no end to the amount of carbon footprint we'll have reduced with this one episode of Mobycast. So let's go. Identity and access management. Let's do it.
Yes. And the way I kind of look at this, so there are a bunch of IAM roles that are either required or you may come across, you may need to use for running ECS. And so I kind of look at it as breaking out into kind of like primary roles and then kind of secondary roles.
Okay. With
the primary roles being ones that, hey, these ones you really should know and be aware of. These are the most likely ones that you're going to be using. And then the secondary roles will be the ones with if you need this feature, then you may need it. So with that, let's talk about some of the primary roles here. So the first is the ECS Container Instance IAM role. This is, especially when running with the EC2 launch type, this is, kind of like the backbone. So this is the IAM role that's assigned to your cluster instance machines. And so that is basically it's used by the ECS agent. So on every one of these machines in our cluster, we have the ECS agent, which piece of code that's running on each one of those machines. It's actually running inside a Docker as a container. And it's going to be making API calls, AWS API calls, right? It's talking to ECS, it's talking to perhaps other services as well. So it needs credentials to do that. And so the way it gets those credentials is through the container instance IAM role. So that's the ECS Instance Role that we'll see pop up in IAM.
So this is I'm sorry, just to make, this is going to be hopefully a very short sidetrack, but AWS roles are sort of prepackaged lists of policies that you can add to your own policy that you're going to use, or right? you're talking about the ECS instance role, and I'm thinking, oh, that's got a policy, and I can add that role to something, and that's like the role's got a list of things that it's allowed to do, and I can add it. I can add the role to I can add it to I don't know. I'm actually getting a little confused here because it's been a couple months since I've worked on this, but essentially, tell me that the roles they have a policy that is a list of stuff that they're allowed to do, and they're predefined by AWS, and I could make my own policy that had the same, I could make my own role that had the same policies and it could accomplish the same thing, and I could use that one instead, or do I have it backwards?
So IAM, identity and access management, there's different ways of categorizing principals. Mm-hmm. And so users is one way, right? So if you actually create a user account, right, that belongs to someone. Right. Yep. John's account or Chris's account, right? That's a user account. Yeah. And then I can have policies, IAM policies attached to my role to give me permissions on what it is that I can do, right? Mm-hmm. Roles are basically the same thing, but they're for services or machines, if you will. But
for non-people, right? Non-users. Right.
So when you're not creating an actual AWS account for it. Mm-hmm. It is specifying this is a principal. This is identifying something, and that's just called a role, right?
Okay.
So that's why we're talking about IAM roles now, is because it's basically, again, identifying a principal, but these principals are services, right? So it's the ECS agent, it's the ECS service itself, it's ECR, it's, whatever, it's our EC2, right? So those are roles. And so for both of those, again, you're going to define an IAM policy, and the policy is going to define what it is that you can or cannot do. Uh-huh. And then you can attach one or more of those policies to users or to roles.
Right. So in this case, this ECS instance role, I guess you just said that you're going to put that on it's going to be a role that the cluster needs to have. Is that something that ECS takes care of putting on the cluster? Where do you basically say, give it this role? And is this role already defined, or is it something that you have to define?
So the ECS instance role is going to be something that will be automatically created for you by ECS when you kind of go through the first time, if it doesn't exist, right? So, and it's going to be done when you're creating a cluster, and you're choosing the EC2 launch type, right? Okay. So it's going to ask you, what role do you want your cluster instances to use? And by default, it's going to be the ECS instance role that I can go ahead and create, right? But at the end of the day, what this ends up being the role that's assigned to the actual EC2 in the launch configuration for your cluster.
So and just to pause here and take a breath for a second. This is the first time we've had to try to have a real conversation about IAM roles and Mobycast, and obviously IAM is like the Achilles heel of AWS, and it's like the hardest little nut to crack for a lot of people as they start with AWS. Chris and you and I just literally tripped all over ourselves trying to talk about it, me in particular. We'll try to keep this going, but I think IAM in a podcast setting may be the most dangerous thing we've ever tried to talk about.
Yeah, well, I mean, if we try to get into the nuts and bolts of it, for sure, but we'll try to keep it again at the kind of like the concept level. So users, you have roles, and that's ways of identifying principals. You can group these things together with groups. So you can have a bunch of users that can belong to a group, and that's another way of applying policy. And then you have the IAM policies themselves that kind of define either what you can do or what you cannot do, and you can what resources you can interact with, what services you can interact with, and whatnot. There are canned managed policies that AWS provides that helps you create these things.
That's what it was that tripped me.
For each one of the services, you'll see service policies. Again, these are managed by AWS. So if you want to go create a role that's being used by, like EC2, or it's going to be run on EC2, or it's ECS, then when you go create one of these roles, that will be, you'll be able to drill down into those options and pick that. And it's basically going to define a trust relationship that allows that particular service to assume a role through the security token service. Which it's kind of hard for me to even. It is confusing, right? I mean, there's a lot here to deal with.
Well, I just figured out, Chris, what I tripped over, and I think at least if anybody thinks like I do, then maybe I can unwind what I was just tripped up over. So here it is. It's that the policies you were just talking about, there are canned ones, and policies are what decide what you can and can't do inside AWS. They're the things like you can run a Lambda, or you can access this S3 bucket, or you can write to it or read from it, or like they're very specific and they're very, very granular. But there's the canned ones, and the canned policies, they have lists of things that you can do. So they might include several things that you can do, and then you can say for what resource, like then you get to specify for what resources they apply to. So if it's a S3 bucket, you can actually list the ARN of the S3 bucket that it applies to. Or if it's a EC2 container instance, then I'm imagining you can probably, supply some ARN of that container instance. But where I got tripped up is that those are the things that are canned and that decide what you can and can't do. And if you're going to use the canned, or that have the option of being canned, and you can like group them together and put them into a role. So you could say, oh, I want administrator access policy, and I want, S3 super user policy, and I want all these different canned policies. But there's some limit to them. And I recently ran into the limit, and it was like 11 of them. And then once you got more than 11, then it was like, nope, you can't do any more than that. So then in order to do more than that, I had to write a custom policy to include the more line item policies of a couple of the other canned policies that I was using. And that was unbelievably annoying to me. And that is where I got a little tripped up. And here's why I got tripped up on it. Because you were just naming these roles, like ECS Container Instance Role as a primary role, ECS Service Scheduler role as a primary, IAM role as a primary role. You're talking about these roles, and just by the fact that the roles have names like ECS Container Instance IAM role, my mind went directly, and I think a lot of listeners and a lot of people that use AWS, their minds might go directly to assuming that this role includes specific things you can and can't do. And that is where I got tripped up, because that is where I started confusing a role and a policy. The role is just, like you said, it's like a way of identifying something, a user or a service. Like it's a way of saying this thing can do this, but it's the policies that say what it can actually do. And so the word ECS Container Instance IAM role does not mean, I don't think it does not mean it can do something specific with ECS. It just means it can do whatever policies you put in that role. And that role is going to live on a container instance, right? Like the role is just a bag of policies.
Yeah, I mean, these particular role names are particular, right? Because this is actually what ECS is expecting, right? It's hard-coded to like, knowing like, hey, this is the role that I'm going to use for this particular piece of code, right?
Okay.
And so it's expecting that particular role to be there. It will create the roles for you. Again, for some of these, it's going to create the roles for you as just a convenience function, and it will make sure that the policies exist as well and apply those policies to that role so that it's all set up, right, the way that you need it to be. So, like again, for just the simple case of like, I'm going in, I click create cluster, it's EC2 launch type. ECS is going to automatically make sure that the policy exists and the ECS instance role exists, such that when you bring up one of these cluster machines, the ECS agent can make it has the credentials to make the calls that it needs to do, right? And you don't really have to do anything. It's just going to all get set up for you, right? Because it's a well-known space right there. So if it's going to go make an API request to do something on a container instance, it's like, whenever I do this, I got to do it as a role. So let me go grab my role that's called ECS Container Instance IAM role. Okay, now I'm going to do it as this role, and crap! ECS Container IAM instance role does not contain policy, and then whatever policy it needed to have to do the thing it was trying to do, that's going to be the error that you're troubleshooting. If you forgot to include the policy that you need. Like that's the most common type of error that people run into. Like I'm doing this thing as this role, and I don't have in my list of my bag of policies doesn't let me do the thing I'm trying to do. Yeah, and so maybe there's a good time to kind of just talk about a default way of setting up ECS would be, you don't really create any additional IAM roles yourself. Each one of your EC2s that are part of your cluster, they're going to be running with this ECS instance role. It's going to then automatically create it for you by ECS. And so again, it's going to be with whatever privileges like the ECS agent needs in order to operate, right? But it's not going to have things like access to S3. So by default, again, if you don't do anything differently, all the containers that you run on your cluster, they're going to actually be running underneath that role. So they're going to be using the ECS Instance Role.
Yep.
Right? And so now if your container, if your application needs to go make an AWS API call to say like S3.
Yep.
So it wants to do an S3 put, and it's using the ECS Instance Role, right? Now you're going to see in your code, sorry, you don't have privileges to do this.
Right.
So what do? You go to the ECS Instance Role in IAM, and now you update it to give it access now to, you apply the S3 read-only policy to it.
Right. And you better hope it's not the 12th policy you need to add to that role.
Yeah. Right. But as we're going to find out, like, you shouldn't be using the ECS Instance Role anyhow for your containers.
Okay.
And we'll get into that a bit more. But maybe for this,
I hopefully, like, I mean, I imagine you sitting there in your car going, my God, these guys. But hopefully, like, me going from absolutely tripping over myself, like trying to talk about AIM to like, I imagine it sounds like I get it now, because I really do understand this. Like, just needed to kind of go through that process of imagining, setting this up and running into the type of problem that you always run into, and just remembering the difference between a role and a policy. Those two things, like, you keep them separate in your head, and the whole system makes more sense.
Indeed, yes.
Sorry for interrupting. I just wanted to ask you a favor. Would you mind contributing to our boat fund? It's that we've always wanted a boat, and we need money from you in order to get one. But seriously, it takes quite a bit of time and effort to produce Mobycast every week, and we do have some small sponsors, but nothing really speaks to us like getting support from our actual listeners. So if you wouldn't mind, go to glow.fm/Mobycast real quick, and it only takes 30 seconds, and just contribute. You can subscribe for $5 a month or $10 a month or whatever floats your boat, or hopefully soon to be our boat. Anyway, if you give us $5 a month, we'll send you a sticker. And if you give us $10 a month, we'll send you a t-shirt. So looking forward to seeing those subscriptions cruise on in. And now back to the show.
So, moving on. So that was the first primary role, right? So the ECS Container Instance IAM role. Another one pretty important is the ECS Service Scheduler IAM role. And so this one it's ECS Service Role, right? And so this is the role. It's used by the ECS Service Scheduler to make calls to EC2 and to the ELB's APIs on your behalf. And so this is really for registering and deregistering your container instances with load balancers.
Okay.
So if you're creating a service in ECS and it's using load balancers, right? Like this service, this role has to be there. And again, it's going to get created for you by ECS when you do some operation where it needs it, as you're like creating a service inside ECS. It's just going to be there. So just something just to be aware of. Like you will see this when you create a service or when you're updating a service in ECS. It'll ask you what the service role should be. And by default, this is what it's going to be using. You can override that, right? You can go create another role if you wanted to have different access permissions or whatnot. But just realize that what that code is doing, right? Again, there's some other specific piece of code, this service scheduler code, and it needs to go make API calls to talk to ELBs to say, hey, ELB, I'm changing your membership set. I need to add this into your membership set. So I need to make that API call. ELB
is like, who are you? And it's like, I'm sorry, I'm ECS Service Scheduler role.
Yes. A third primary role would be the ECS Task Execution IAM role. And so this is, the name for this one is ECS Task Execution Role. And so what this is the role used by your task. It's actually used by the ECS agent to make API calls on your behalf of a task. Typical use cases for this would be if you're pulling images from a private registry and need to make certain calls for that, or if you're referencing maybe like sensitive data in your task definition files, like to go talk to secrets manager or parameter store, right? So those are other API calls. And so it only applies to the task, right? Like it's the task that's doing that operation. So that's why this is the task execution role. And so it's separate from these other ones, right? Because it's at a different level of granularity. With the EC2 launch type, we don't typically kind of like think about this role too much, because usually the ECS Instance Role is filling in for this. But when you're running on Fargate, there is no ECS Instance Role.
Okay.
Right? Because you don't have an ECS instance. You don't have an actual EC2 instance that you're running on. It's on a Fargate instance. So you need to specify the task. You have to use this task execution role in that case for Fargate. So and you're going to need that for doing things like pulling a container image from ECR, or pushing logs to CloudWatch. Those are all.
Yeah, like the example we gave before was talking to S3. So if you're going to talk to S3, you need to add that. You need to add those policies into the task execution role.
No, that's going to be different. So okay. This is outside of your code itself, right? But it's related to the task and operations that the task has to do. So that's why it's like part of the task lifecycle. In order to initiate it, it needs an image, and so it's got to go pull an image from somewhere, and that requires this API call, right, to do it, right? So
yeah, I think we left last week. We left the difference between tasks and containers that are inside of tasks like a little fuzzy, and so this again is like, ooh, that's in that little like fuzzy area that I kind of stepped in last week, and I'm nervous to talk about it this week too.
For now, for this discussion, we can just say task equals container, because we don't need to worry about the nuance that tasks are really a collection of 1 to n containers. But again, in typical cases, there's only one container per task. And so whenever I'm saying task or container right now, they're interchangeable. Okay,
except that they're not, because the running container is not using the task execution role to do the work that it's doing.
So maybe to clarify that, by that I mean it's you think of it like the task manager.
Okay.
Whatever credentials the task manager needs in order to instantiate that task and deal with both input and output.
Okay.
Right? Again, an example would be CloudWatch integration. So you want to use like the AWS logs driver with your task, which essentially just means whatever goes to standard out, that gets captured, and then it has to get shuttled over to CloudWatch. So your task itself doesn't know anything at all about CloudWatch. It doesn't have to make any CloudWatch calls whatsoever, right?
That really helps.
It's up to it's actually the ECS agent. It's something else outside of your application code, right? That's saying, I'm going to go I'm trapping standard out, standard error. And now when I have that, I'm now going to make these calls to CloudWatch on behalf of this task, essentially, to go put that data over there. And again, likewise with ECR, like this task needs to start up. Well, I have to go get its code, right? I need permissions to do that. The container's not even running yet, right? But it's still, that's right. A task-based, it's at the task level, right? It's just granularity wise.
And it's so funny, because all you have to say is it's like the task manager or task management execution role. And it's like, I hope you're listening, AWS DevRels, because naming matters. It really matters. And all you have to do is add that word, and all of a sudden it's like, oh, I get it. It's not the same as a task. It's not the task. Naming matters. Everybody, naming matters.
All right, so homework for you, Jon. You can submit the pull request to Amazon for the name change.
It's not open source.
All right, so those are the three primary roles I wanted to talk about. There's some secondary roles, and we'll kind of go through these pretty quickly. But they're related to some of the other features and integration points that you can have with ECS, and so they're all related around things like autoscaling and CloudWatch events and code deploy. So ECS, you can if you configure autoscaling for your actual ECS service, which we touched on, earlier in this episode, then it's going to be making calls to manage that scaling for you. So it needs a role to do that, and so that's the ECS autoscale role. So you'll see that, again, it'll be automatically created for you if you enable application auto-scaling for your ECS service, and it'll, by default, has all the permissions that it needs in order to do those kinds of operations. The CloudWatch events IAM role, that's the ECS events role. So if you ever, if you want to run a scheduled task in ECS, this role will have to be created. And again, going to be done by default for you as a convenience.
Which direction is this going? Is this saying CloudWatch is going to kick off something in ECS, or is this saying something inside your ECS stuff is going to kick off something in CloudWatch?
So what happens is this ends up, ECS creates a CloudWatch events rule, and then you define the policy of how often this thing fires. And then when it fires, it's now executing an ECS job, right? So this policy is giving CloudWatch permissions to run ECS tasks on your behalf.
Okay.
And it's also giving ECS permissions to create the CloudWatch events as well.
Okay.
And then the last one to talk about would just be the code deploy IAM role. And so this is if you choose to do the blue-green deployments option with ECS, which underneath the covers, it's powered by code deploy. So it needs access to make calls to code deploy on your behalf. And so that role will be necessary as well.
So again, it's ECS calling APIs of code deploy under this role?
Yeah, it's whatever is needed to make that happen, right? So it's usually two sides to it. Like we talked about with the ECS events role, it's one, the CloudWatch event that actually has to be created using the CloudWatch API. And then it's also the permissions to CloudWatch to execute the ECS task on your behalf. So there's trust relationships involved here so that, again, using security token service, these services can assume roles to go do these things. And so it's just that for each one of these, it just depends on what it...
I'm not going to let this go, man. Like something that is code has got to assume a role and then go make some calls saying, hey, I'm this role. And I guess what you're telling me is that in the case of CloudWatch events and code deploy, that some code in the code deploy service is going to assume this role and call some code and call some APIs in ECS. And some code in ECS is going to assume this role and call some APIs in code deploy. It's going both directions. And you're saying the same is true for CloudWatch?
Right.
Okay.
Yeah. So, and what it's doing, right, is it just needs to have that role, and by giving it the trust relationship, it allows it to temporarily assume the role. So it can change its identity. The code that needs to do this, right, it can change its identity temporarily to go make these calls so that it's done in the right context. Mm-hmm. And so, again, it's it
goes assume role, and then it's going to go grab the role it's going to assume, and then it's going to make the API calls. And the API calls are going to be like, hey, what's your role? And then it's going to be like, here's my role, and here's all the policies inside of it. And then the APIs are going to be like, cool, come on in, mm-hmm. or not. And that's the easiest way to think about it. I'm some code. I'm going to assume a role. I'm going to get asked what my role is, and the role is going to get handed over with all of its policies. And then those policies are going to get checked. And that's it. That's it. And so when I'm like, which direction does it go? It's because I'm trying to imagine in my mind which service is doing the role assumption and doing the API calling. And what I heard back was a little confusing to me because I was like, wait, is it both services assuming the same role? And I guess the answer is maybe yes. Mm-hmm. Cool.
It just depends on, again, the situation. So like the CloudWatch events, the scheduled task is pretty easy to think about because it's two main things have to happen, right? One, the CloudWatch events rule has to be created, right? So now a CloudWatch mm-hmm. API has to be invoked to create that rule. Someone is doing that. That's ECS. So ECS needs to be able to make that API call to CloudWatch mm-hmm. on behalf of you, right? Mm-hmm. And then the other aspect to it is now when that event rule, when that fires, it's now going to go make an ECS call to run a task. And so now it's making an ECS API call. And but it's the CloudWatch service that's making that call, right?
Mm-hmm. So now it's doing the role assumption. Mm-hmm. Yeah. Mm-hmm. Cool. Yeah. I get it.
Good.
Yes, I get it.
All right. So now moving on, a really kind of important, to kind of wrap up this whole IAM discussion, a really important point is, so the principle of least privilege is pretty good thing, right? Like for having a good security posture. As I kind of alluded to previously, the ECS Instance Role like by default, that's what your task, that's the role that they're going to use, right? To go do their whatever access they need. So you may have, say 5 different services running on your cluster, your ECS cluster. And each one of those things are doing, different things. Maybe some of them are making calls to Kinesis, and some are talking to S3, and some are talking to SQS and SNS. Maybe others are talking to, I don't know, Lambda, or maybe some like transcribe or something like that, right?
Okay.
And so they all have to, need credentials to do that. Again, by default, maybe they're all going to be, you set them up so that they're going to be using that ECS Instance Role. So that means that ECS Instance Role needs to have the superset of permissions that all your containers need, right?
Mm-hmm.
So that means that, all your containers can do what they need to do, but it also means they're over privileged, right?
Mm-hmm.
Because now your simple little app that all they need to do is go read a particular key from an S3 bucket. Now it can go do all this other stuff, right? It can go hit Kinesis, and it can go talk to CloudWatch, and it can do transcribe
grab
calls.
some secrets.
Yeah. It has access to a KMS or whatnot.
Right.
So we really should be thinking about doing permissions and identity and access management at the task level.
Yes.
ECS allows you to do this. It's IAM roles for ECS task, or it's task-based IAM roles. But really what it is inside when you're defining a task in the task definition, you can specify this role that it should be used as the task role.
Okay.
So that's a parameter in your task definition. So really what you want to do is you want to go and create a role for each one of your services that has the minimal amount of permissions that service needs.
Mm-hmm.
And so don't share amongst your containers really in your services. Have it on a per service basis, and that way it's locked down, and you're not over provisioning what kind of privileges your services do have.
Right. Yeah, that makes a ton of sense. And that's really straightforward. It makes sense to do, like, I can imagine doing that inside the console. I can imagine doing it inside of like a CloudFormation. Like that's the one role that makes a ton of sense and is easy. It's all the other roles that are so hard to get your head around. Like, wait, you need a thing that can talk to ECR? Like, I wouldn't have thought of that, right? Like, all those are the hard ones. It's the thing that your actual business logic needs, those things that your business logic needs access to. That's the one that's easy.
Mm-hmm. The good news here is that all those other roles we talked about, for the most part, they're going to be created for you and managed for you. And it's only if you need to like tweak them would you actually have to go and do anything with them.
Right.
But it's good to be aware of them and just know that they're there and why they're needed.
Right. Because it looks like just detritus, right? Like it's sort of the like entropy of using AWS. Like, oh yeah, I was messing around with ECS and now look, I've got 7 new roles in here for some reason. I don't know what they are.
Mm-hmm. Yeah. And this is, so now we should have a good understanding of why that is there. But yeah, task-based IAM role is pretty straightforward and easy to understand. Again, we don't want to use a common one that's shared across all of our services. Instead, we want to create it on a per service basis. Really easy to do. We first create an IAM policy that's, again, specifying the minimal permissions that we need for that particular service. After that, we can create an IAM role for that particular task, and we attach that IAM policy to that role. With that particular role, we're going to be creating it based upon the ECS task role service role that's provided by AWS, right? So again, that's when you go and create a role, you're going to get a choice of, is this a service role or is it a custom role or whatnot? So when you click service role, you'll see a list of all the different services, that AWS offers. So we're going to drill down to the Elastic Container Service, and there you'll see about 4 or 5 different specific roles. One of those is going to be the task role, right? So we're going to pick that and then attach our IAM policy to it, and that's about it. And now we can specify that in our task definition file. And this applies to both launch types, right? Whether we're running on EC2 or we're running on Fargate, we can use this.
Yeah, it totally makes sense. So did you imagine that we'd spend 50 minutes talking about IAM today?
No, I didn't.
Should we get started on the episode?
Yeah.
Let's get started.
Yeah. So that was the first important thing we want to talk about was identity and access management for ECS. The next thing is to talk about networking, container networking. Because this is, again, going to be another one of those important things to specify when we're creating our task, especially now in the Fargate launch type.
But Chris, I don't think we can do it. Like, honestly, I'm going to have too many questions about container networking to be able to blaze through this in 5 minutes. Like, I'm not sure. What do you think, listeners?
Yeah, I think we could probably talk about this in 5 or 10 minutes, but it's interesting enough where that probably would not do it justice.
Right. Yeah, that's what I'm afraid of. Because there's definitely some more squishy stuff in here for me. And I think it's that squishy stuff when you make it solid for me. I don't know. That's why I do this. Like, that's why we do Mobycast, is because it's so fun to get from that, like, I'm not sure, to, oh yeah, I get it. So I want to do that with networking and not just be like, oh yeah, Chris said a lot of hard words really fast and I let him go without stopping him.
All right, fair enough. So this is part 1. So next week we'll pick it up with container networking and dive into all the various different types of networking modes that AWS supports, that ECS supports.
Cool.
And really kind of understand, like, what's the difference between Bridge versus AWS VPC, which is really the two big ones that we need to understand, where Fargate requires the AWS VPC versus usually when we're running on the EC2 launch type, we're using Bridge, but just kind of understanding the differences between those.
Cool.
And then after that, then we can actually get to the process. Okay, like, what are the nuts and bolts now of migrating from the EC2 launch type to the Fargate launch type? What are the changes we need to make?
Right.
So we'll get there.
Guess who's not going to talk about the weather next week? All right. Thanks so much,
Unless
Chris.
there's a blizzard.
Yeah. Thanks so much, Chris. This was really fantastic.
All right, great. Thanks, Jon.
Talk to you next week. Bye.
See ya.
Nobody listens to podcast outros. Why are you still here? Oh, that's right. It's the outro song. Come talk to us at mobycast.fm or on Reddit at r/Mobycast.